how much work does it take to compress a spring with a spring constant K by a displacement X? And so I've drawn here a picture of a spring that's going to be compressed. That's at least what that arrow there is meant to represent. Maybe it represents the force that's going to do it. So, okay, like how can we approach this? I'm going to draw a graph over here. We know that work is equal to force times displacement, but the issue is the force here is not constant. So let me draw a graph of force versus compression. In other words, F versus X. So the variable X represents how much the spring is compressed. And in that sense, with the spring uncompressed, there's zero force, and it would start at the origin here. And then since F is equal to Kx, the graph should just look like a line kind of like this. And let's actually terminate it at a particular point here. So if we say that, hey, that represents the final total compression, you know, maybe since I've already used the variable X here, I should call it X sub F. But I'm just going to say, you know what, that's the final compression X. And in that sense, if I said, okay, if that's X, then the force that's applied right there would be equal to K times X. But the average force, I think it would make sense. Let me kind of draw here like a, I don't know, pseudo dotted line. I don't always do dotted lines very well in this program. I don't know if I got it quite half there, but maybe that could represent what the average force applied to the spring is throughout this displacement that compresses it. And if that really is halfway, then that is equal to 1/2 kx. So maybe that will lead us somewhere. Let's actually go ahead and check in with the answer on this one. It's a formal example, so I usually relax the rules a little bit, and sometimes we'll look at the answer early. And you can see that it's already suggested here. It says the force is F is equal to Kx. It might make sense the average force applied over a total displacement X is equal to 1/2 Kx, which is basically what the conclusion I've drawn from this kind of graphical analysis. This isn't really a mathematical proof, mind you. It really would take calculus to prove some of this stuff, but hopefully at least it kind of makes some conceptual sense. And then since work is equal to force times displacement, I'm going to argue that for force, if we're just going to use the simplest rule for work, force times displacement, the appropriate thing to put in here is not the force that is only really applied when the spring is most compressed, which would be Kx, but to imply or put in there the average force applied throughout the displacement. So that means I'm going to put in here, if my argument is correct, at least 1/2 kx. And then d is the displacement, but we really said the displacement was also an x, so that's 1/2 kx times x, which is really 1/2 kx squared.